Performance and efficiency cores are the hottest trend right now in the processor space. But why do we need them, and what could they evolve to in the future? To start with a little bit of history, back in 2020, Apple revolutionized the laptop computing space with their new in-house designed M1 chip. Of course, it garnered criticism for many reasons. However, the one we care about is its hybrid design. You see, the M1 processor technically has 8 cores, but not all cores are created equal, as the M1 has 4 efficiency cores and 4 performance cores. This split design is why the chip is referred to as hybrid. The M1 design differs from other processors, as in other chips, especially in the laptop and desktop space. Typical processors have X amount of cores that are all firing equally. For all intents and purposes, they all can perform to the same level. However, in a hybrid model, the low-power, lower-performing efficiency cores are used to compute simple, everyday tasks, while the 4 additional performance cores, which run hotter and draw more power, give the machine more horsepower when it needs it. The utilization of efficiency cores allows for improvements in thermals and power draw, which when applied to a laptop means much more power efficiency, resulting in better battery life. The split approach to computing seen in the M1 was fairly new for full-size chips, especially as Apple planned to put it in a mainstream laptop, namely their 2020 MacBook Air for starters. After the laptop was released, it received critical acclaim. Hardware Canucks, a PC-focused YouTube channel, even went so far as to claim the M1-powered MacBook Air was, quote, the best computer we have ever used. And if you'd like to see our thoughts on M1, check out my video here. So with such positive reviews, the rest of the industry collectively said, maybe Apple is onto something. Shifting our focus to the PC hardware space, as that might be why most of you are here, for their 12th gen, codenamed Alderland processors, Intel opted to use a hybrid design similar to the one seen in Apple's M1. This was particularly interesting, as this had never really been done at a desktop level before. Furthermore, while Apple had the luxury of building their own ARM-based architecture to power the M1, Intel had to create the systems to be able to get the hybrid design to perform for an already existing x86 architecture design. No small task indeed. But Intel was able to do it, and their Alder Lake processors actually worked really well in implementing a hybrid design. Intel implemented what they call a thread director directly into the microcode of the Alder Lake CPUs, which communicates with the core scheduler of a given OS to assign computes to either the efficiency or the performance cores based on the instruction set of a given task. While this technology is all fine and good, when battery life isn't a concern on the desktop environment, why implement a hybrid design in the first place? The answer is quite simple, as it's the same for the laptop computing space: efficiency. Overall, the hybrid core model allows for less power draw from a machine, which in the case of a desktop means significantly less heat. This means a number of things, including less energy used to cool the space the machine is in. What it also comes down to is trimming down the excess of what's really needed. After all, do you really need a core firing at full 5.3 GHz for web browsing? No, so why waste the energy to do so?
Because I can.
Fair. So now that we know a little bit of the history and function of hybrid chips, at least in the full-size space, let's take a look at where things might be headed in the future. It's no doubt that hybrid chip designs will be the future of laptops, as the efficiency gains there have the most real-world benefits. Apple will double down with their future M2 chips, and Intel will continue to port their desktop chip designs to mobile. The biggest question remains how AMD will handle the way the industry is unequivocally heading. AMD is really just now beginning to hit their stride with their processors. That is to say that they have long since caught up, as it were, and with their clock speed improvements coming up, they could actually be looking at outperforming Intel in single-threaded performance. But with that being said, AMD has been experimenting with pushing new cache technology to customers, as opposed to hybrid chips. How easy it will be for AMD to pivot to a hybrid design on their Zen chips, it's hard to say, or even if AMD will pursue a hybrid design in the first place. Giving my honest opinion, I wouldn't be surprised if AMD only brings a hybrid model to their Zen laptop chips and leaves the desktop with a familiar design. As for the actual technology of hybrid chips, I wouldn't be surprised if chipmakers began experimenting with a dual cache design, that is, having a separate cache feeding the efficiency cores and a separate cache feeding the performance cores. Perhaps with advancements in cache stacking tech, like AMD's 3D cache found on their 5800 X3D, this would be achievable. Such a design could further benefit the efficiency gains of the hybrid designs. And with all that, I hope you enjoyed this little bit of a dive into hybrid chip design, and I'll see you guys in the next one.